Greetings, Dave Dickinson here from AstroGuys.com, and I thought I would try to do something that I haven't done for a couple weeks here, but I wanted to do another pre-post show for the weekly Space Hangout. I think time-wise it's going to flow better if I do it as a, hey, I got one viewer, cool. Do it as a pre-show periscope here to just kind of warm up and talk about what we're going to talk about and maybe go a little deeper into some, oh, we got a few more viewers, cool. A few things that we're going to be talking about. The biggest thing we've been doing this week was the AstroH satellite. We've been writing a lot about that. I've got an article up on Sky and Telescope right now. And by the way, anybody let me know if my connection's good. I'm on hotel Wi-Fi here at Norfolk Naval Air Station, but the Wi-Fi seems pretty good, pretty stable. I notice with Periscope, unless you have an absolutely stable connection, you don't necessarily get a good broadcast here. But I've been wanting to try to do one of these periscopes at least once a week, archiving them up on YouTube. Hey, Guido Bibra, one of the weekly Space Hangout crew is on there. Good to see you on there. Anyway, AstroH launched a couple mornings ago from the Tanegashima Space Center in Japan. Went into a very Hubble-like orbit. It's in a 31-degree inclination orbit. This is an X-ray observatory in the biggest satellite that JAXA has ever lofted atop an H-2A rocket. Didn't get to watch this launch. It was at an odd hour for the U.S. East Coast. I watched the replay. There was some very cool photos that we're taking on site of the satellite, the launch near the moon. It seems that it deployed well. There's going to be about a 3-month checkout phase for this X-ray observatory. And a lot of people have asked me, and I kind of researched this when I wrote the article too for Sky and Telescope, what the difference is, the fundamental differences between this and NuSTAR and Chandra, two other high-profile X-ray observatories up there. AstroH, which was renamed Hitome, which in Japanese means the pupil of the eye. I guess there's a new eye onto the universe with the X-ray, has the capability of observing both in soft and hard X-rays, all the way up into low gamma rays, actually, with the 6 instruments that are on board. Kind of a capability that Chandra and the resolution is much higher on this one too. It's much higher than what Chandra or NuSTAR. It gives us that kind of extra window right up into the gamma rays. So we're going to see some interesting science coming out of this, especially looking at black holes and other X-ray sources out there. Black holes have been in the news a lot lately with LIGO and gravitational wave detection. I'm hoping to talk a little bit about that. I couldn't make it to the last week's Space Hangout. Last week was especially crazy for me, and it happened to be the week when the announcement of the detection of gravitational waves by LIGO came out. Did not make it to the press conference, unfortunately, but I'm hoping. I did write an article on Astro Guys today, finally, on my 2 cents on the detection, because we've been following the LIGO story for a couple of years, most of our writing career. We've been to both LIGO detectors. And there's also been some very interesting news the last few days that the Fermi satellite may have detected a gamma ray burst that was about 0.4 seconds right after the detection by LIGO. So they think there may have been a transient that is linked to that black hole merger that LIGO saw. So there's been a lot of interesting news. Hitome AstroH is kind of a very interesting project that kind of slipped through the radar this week and didn't necessarily. Another thing I'm writing about too, I've been writing about James Webb. There's also been talk about the WFIRST, and I'm writing about this for Sky and Telescope next week as well. The WFIRST satellite, NASA just unveiled this new infrared satellite that they're going to be putting out in about a decade that's going to be going up into orbit. So, we're getting a few more people joining. Yeah, so that's probably what we're going to be talking about in the weekly Space Hangout. We're usually kind of crunched for time. I have been writing up observational science right now, astronomy. There is a very good pass, incidentally, of the International Space Station. We're here again in Norfolk, Virginia right now. We're trying to catch a flight out to Rota, Spain, by the way. We've been trying to do it for about a week. Hopefully, come this Tuesday, we're going to catch it. There was an undocking of the Cygnus spacecraft from the International Space Station this morning, and there's been some discussion amongst us folks that like to hunt for the International Space Station and such things every time they pass over, that tonight we might see Cygnus is going to do a destructive re-entry. Unlike the Dragon capsule, it doesn't come back to Earth. Dragon is the only uncrewed capsule that has downmass capability from the ISS that can bring cargo back. Cygnus has done its job, and it is going to burn up tomorrow morning. But it undocked this morning, meaning that it's going to be in the same orbit with the International Space Station. And I have not seen updated orbital elements. I've been hitting up Space Track, and they have not updated the orbital elements. They still show it as the International Space Station. Cygnus docked to the International Space Station. It usually takes about 6 hours, and it undocked about 6 or 7 Eastern Standard Time this morning. So if you got to pass the International Space Station tonight, my advice and what I'm going to be doing, I'm going to try within an hour prior. I'm at AstroGuys with a Z on Twitter, for those who don't follow me. I'm going to try to hit up Space Track about an hour prior and see if those orbital elements are updated. What I'm doing is I'm pulling down these 2-line orbital elements, inserting them into Orbitron, which is a program, a freeware program you can download and run on your laptop. And I'm looking to see where it's positioned. This is a little more accurate and a little faster to get those kind of swiftly changing information than Heavens Above, the way I do it. I will try to tweet out a orbital snapshot of the position of Cygnus versus the ISS if they've updated it prior to. If they don't update it prior to, what I'm going to be doing is I'm going to go out there with my binoculars, and I'm just going to look a few minutes prior to the ISS pass right along the same trace of the orbit, and look either right before or right after, and see if Cygnus will be fainter, but it should be visible. It probably, the ISS is usually comparable to Venus, like -3, -4. Cygnus will probably be +1, +2 magnitude, but it should be naked eye even from here in Norfolk. So it'll be kind of cool to see it right before it docks, or undock, right before it re-enters tomorrow. It's undocked and done its job. And there is another Cygnus launch. I think it's without looking, I think it's the 24th of this month. There is another, is it Cygnus? It's a launch out of the Cape. It may be a Dragon. You know, I'm not certain without looking at anything right now, but there is another launch. I know there's got to be more Cygnus spacecraft going up there. So that's what we're going to be talking about. We're going to be talking about Hitome, formerly known as AstroH, X-ray astronomy. We're going to be talking about the LIGO, if we talk about LIGO. I think there's going to be some discussion because it's been the big news of the week. We're going to be talking about WFIRST and James Webb, if we can talk about those. And it's interesting, you know, because there's a whole plan for a whole succession of new space telescopes. The thing that's cool at WFIRST, because I've been reading and researching this right now, is that it has a much wider field of view. That's the WF is wide field infrared satellite. And these actually were a pair of space telescopes that were gifted to NASA by the National Reconnaissance Office because they had some extra spy telescope mirrors for whatever reason they decided not to use. These are Hubble class instruments, about the same size as Hubble, and WFIRST is going to be going up to, like James Webb, the L2 point, 4 times the distance of the moon in the anti-sunward direction. It's going to be operating from there. But I've heard the question, and I kind of wondered this when I first heard about WFIRST too. I'm like, okay, what's the difference between WFIRST versus James Webb, which is already going up in a couple of years? And well, it's going to have a much wider field of view. It's going to be able to complement, I think it's going to be a purely IR instrument too, where James Webb is in that visual to near IR. And beyond that, we've written about in the 2030s, and this is way down the road, but it's going to be kind of cool to see. They're also talking about the high-definition space telescope. This is going to be about 3 times. This is very much in the proposal phase right now. WFIRST construction and planning is getting underway now for a launch in about a decade. The high-definition space telescope would be 3 times. We're talking about the telescope after Hubble right now that they're designing. Like, you've got Hubble still up there. They'll use Hubble as long as they can. They can't repair it anymore because we don't have a shuttle unless they come up with some robotic automated way to repair it. So if Hubble loses any of its fine guidance or anything, which they had to repair in the last on STS-125, if they lose that, then James Webb is the replacement, but it's more of an IR instrument. And then we're going to have after that, we're going to have WFIRST, and then we're going to have the high-definition space telescope, and who knows what beyond that. You know, there's been crazier ideas about gravitational lensing telescopes put out in the Kuiper Belt, or just, you know, you're getting into real Tomorrowland kind of things. All right, well, we're about 15 minutes away right now from the weekly space hangout, so we'll probably start gathering for that here very shortly. If there's any questions, I'm giving the 1-minute warning now before I shut this broadcast down. This t-shirt, by the way, I always like to try to wear this to give Michael Zeiler Eclipse Maps a little extra plug for the 2017 eclipse. We're within a year now. Matter of fact, the last total solar eclipse prior to the 2017 eclipse is going to go over southern, at this next new moon in early March. It's going to go over Southeast Asia. Didn't make this one, unfortunately, but the 2017 eclipse, we are going to make that one. So that'll be my first total solar eclipse. I've been to an annular. I've seen many, many partials, but fortunately, our path is finding us heading toward Europe and Spain right now. We're attempting to. That's why we're here at Norfolk. So right now, just stay tuned, and we will be writing about the March eclipse, the big things coming up in observational astronomy. We wrote about the gathering of all the planets in the morning sky are ending. Mars is going toward a fine opposition this year. Jupiter is just about at opposition and moving into the evening sky here in March. And Mercury is going to be transiting the Sun in May on this next half orbit around. So that's going to be kind of cool. And we got the total solar eclipse. So there's going to be a lot to write about. So stay tuned. See you on the weekly Space Hangout.